So I would say that you can help your, and you're trying to finish all of your other classes at the same time, and then you have, well, you won't love Professor Brown, and these guys love me. And I may not be available, and I'm gonna, I'll get around to looking at your stuff when I do, and hopefully you graduate because you did it in time. I know it's kind of harsh, but there's this big crunch at the end that you can absolutely avoid. Write a little bit as you go, get it all figured out, right? And they never do it.
Yeah, well, we talked about that. I had you guys, you were a little bit organized, right?
Yeah.
You were completely impervious to my suggestions.
Yep. For a while.
Any other questions?
Oh yeah, just another point on what the Professor said. Professor Brown likes to travel a lot. During A and B term, he wasn't on campus that often, so the time between meetings or doing a Skype meeting, it can be a while before you see him face to face. That's not an excuse to not do things, because just because you can't actually meet with them, you should definitely take it as an opportunity where you don't have to. Don't think you're like off the hook while he's not on campus, because he still finds out that you didn't do stuff if he's in your environment. Just meet with him in Skype, and he'll still have the same kind of critiques and comments, but he just can't yell at you right there. Make sure you still are doing things, even if he's not around.
Well,
Yeah, solving the technical part of the MQP is actually pretty straightforward. It's the problem definition is the hard part. You can solve any problem anybody gives you. It's trying to figure out which problem to solve. And I've done, 8 MQPs now with axiomatic design. And so there's a hurdle where you got to kind of take ownership of the axiomatic design process and kind of get it. And then there's this gnashing of teeth where the students are sitting in the pub for 4 hours trying to figure out what's supposed to go in the matrix, right? And they go through all that. But by the time they get that figured out, when they go to solve the problem and write the whole thing out, wow, the thing flies, right? Because you've already figured out what the problem is and how you're going to approach it. So it seems like, I don't want to learn design, I want to be an engineer. Well, the engineering part is really is the small, easy part. The hard part is you got to figure out what problem you're trying to solve. And they were very thankful at the end. They're like, the thing went really pretty easily along after we built the matrix and figure out what we were supposed to do.
that's an interesting way to look at it. I mean, so what was the problem you were solving here? Can you describe it?
All right, so this is the head tube joint of the bike. So the front fork goes here, where the front wheel is, the handlebars are here. And this top tube goes over where the seat is, this goes to the down tube. So the problem that we were solving, or we were trying to do, was transfer all of the moments on the bike from where all the tubes were, because that's what a joint does. So we had, just take this out, because it's not even relevant. So these top two tubes don't want to stay stationary. All the forces on the bike, they want to move in basically every direction. So this serves the purpose of transferring all of those loads across each of these tubes from each other. So we look at, I guess it's probably easier to draw it, but say you have these two tubes. This one wants to go like this, and so okay, I'll draw it. That's a good idea.
So let me pick up on something. Transferring the loads.
Yes.
So what's the FR for a joint? Transferring the loads. And another term that you use that you could talk about is maintaining the position between these critical elements. What colors would you like?
Oh, an eraser. I'll just use my words. All right, so we'll just use two as an example. So say this is the head tube, and this is the top tube. All right, so when all the forces on the bike, so let's just say this tube wants to go in either of those directions. So it wants to do this, right? So how do you, transfer the moment? you want to stop this from moving there, right? So if you stop it here, you're creating basically a fulcrum on this end point, and then this point wants to move. So if we stop it here, that stops, but now this wants to move, right? So you also have to stop it here. So what could, transfer that moment from this to there? Well, if you just connect this to that, this stops it, this whole movement area, right? So if you stop at the bottom, it still wants to move up this way, right? So what you do is you do the same thing. You just put a big block, connect it, this connects to there, this connects to there, stops the moment. Now, you don't have to have all of this, space, you can turn it off, but that's, stuff later. With this, that gusset, so this big piece in between these two serves the purpose of what these two blocks did. So it transfers the moment from this tube and this tube to the head tube, like that. And instead of having a big block up top, since there wasn't enough room, the head tube, we just put straps over it, post clamps, and that served the same purpose.
Did you guys use any simulation software to test it before that? Or did you
The
just-
only simulation we did was force simulation through SolidWorks, just to test, the integrity of the joint to make sure it would work. We didn't do any, dynamic loading. We couldn't figure that out, so we left that out. But that's all we did.
You did finite element analysis.
Yes.
Yep. Right. Yeah. And the thing that was the problem was your lack of skill as a welder.
Yeah.
Yeah, you could have done it. Great. Anything else? Okay, so give me just a minute to pack up, and I'll head over to my place. How many people can come over and get some refreshments? Oh, you got something? Come on up. I was going to talk. Sorry. Yeah, good. Please, come on. I didn't see you raise your hand when I said who wants to say something.
Oh, I raised it.
Oh, I missed it.
I'm actually going to pull up our video.
Oh, great. Super.
So I'm Jared Heiser, everyone. I'm in ME, and our group was given the task of coming up with a load-limited prosthetic device for amputee below the knee. So pretty much everything they said, I got the same suggestions. Hold on, let me finish.
I must not be doing a very good job of communicating this stuff.
Well, we got the axiomatic design idea, but back to what the professor said, it's all about solving the right problem, because don't show a whole picture. So everyone's pretty familiar with what a foot looks like. Not like that. So basically in your foot you have, or like for a prosthetic person, it connects to the rest of their foot, this ankle joint and toes. So when we were first designing, we were like, okay, well, what do they need to happen? And we were really focused on backwards motion, because if you don't have an ankle, you can't flex your ankle forward. And we were all caught up on that. We had all these FRs, and they weren't right. And then we sat down one day, we said, okay, well, what do we have? So we have, this is the part where it connects to the rest of the patient. And this rotates, this arch absorbs the load, and these toes flex. And those were our FRs that we used, and it worked out really good. We just had a natural model to go off of. So with that problem, it really, things became much simpler, and we could figure out ways to change this without changing the ankle without doing this. And then to break them down even further, you had your ankle, okay, well, rotation, what is that? And then, rotate around the X, the Y, and the Z, and figuring out ways to individually, limit all of them. So I got a video of our thing. Let's see if it pops up. This is who we had test our prosthetic. So here's him. This is him walking with his prosthetic, which is like a $20,000 K4. It's like for basically athletics, and this is our prosthetic. Notice we have a spotter walking next to him. Should it go wrong, and just showing how it works. And then when we get to this is where it really did good. It's like the incline and decline. So we're rather proud of this. So if you look at him going up, he's kind of staggering, and also coming back down like the same thing. It's kind of like uneven. So when we go to ours, if you look at him, it's nice and smooth. So that our design with the ball joint lets him walk up and down hills easier than his one that costs a lot more than ours did. So that's something cool that he said. Just kind of like an ad for Axiomatic Design. The way we split this up and viewed, okay, what does a foot do, allowed us to do this. Whereas other prosthetic companies, everybody's seen like a carbon fiber, like a foot or a blade. Those simulate the same motion, but they're not necessarily doing the same thing. It's not like an ankle joint. It's something that if you step on it, it feels like an ankle, but it has problems of its own. So that allowed us to do that, and it worked out pretty good. We won the Provost Award, so we're happy about that. Another point, especially for the mechanical people, I said in one meeting in C-term, we were ready to manufacture, and I think I said we would have it done in a matter of 2 days, and you just laughed. It took us all of C-term and the better part of D-term to manufacture it. So for mechanical, if you're going to use the shops in Washburn, make sure that you know the programming. If you order metal, this is something I didn't know. We need, we had our parts, and we said, okay, well, we need this much and this much, and we just ordered a big brick of aluminum. That's very hard to cut, so don't do that. Get little thin sheets. It'll make things a little easier. But yeah, make sure you look at like Esprit and remember that. Definitely have a group manager. That helps. Just make sure, especially when you break up the FRs, something that we did. We had 6 people in our group, so we all just assigned different people. Said, okay, 2 people take this FR, 2 people take this FR, and that way, it's kind of like a little competition in your own group. So you're like, okay, who's going to come up with the best design? So that's a really good way to do things, and another plus to Axiomatic. What else? I had a fun time. We made something cool, and it's still going. So.
Go tell them what the guy said.
Oh yeah, it's what he said. He said that.
Oh, there. Oh, you got it up there.
Yeah,
Yeah.
he said it's the best feeling he's had walking up and down an incline since he said 95, which I'm guessing is when he lost his leg. So
what advice do you have to the School of Business students that are going to get involved with this?
definitely split it up like that. Make sure we would have. When we broke up our FRs, we know what we wanted to do. We each came in with, I think it was 5 solutions for each FR. So you basically say, okay, here's our FRs, you do this, you do that. Everybody splits off, you come up with your individual FRs, and you come together and you kind of discuss all the different FRs for each thing, just to make sure the whole group is kind of on the same page. And also, say I'm designing the toes and somebody's doing the ankle, something about, or I don't know what the business simile this is, but if somebody has one idea and you say, oh, that would also be good with mine. So it's just kind of like, it's just more ideas, but it's also being filtered in an effective way. So.
Let me speak to that too a little bit, and for the management people in particular. Designing the design process, like the Norman Rockwell thing. So if you have components that you can maintain the independence of, you can have different groups working on different parts of this, knowing exactly what the interfaces are, and knowing that if I change something here, it's not impacting it here as well. So we're trying to maintain the independence. So if we think about, oh no, we've got to change something in the toes because we didn't get that right, we have to change something back here too, and knowing what the interactions are from your design matrix. So the design process applies to the physical element as well as the process for designing it. So if you've got a decoupled design process and a change comes in, You know exactly what that's going to impact, who has to be involved, and you take care of the change. But this was neat though, because it ends up with 8 leaf springs to
Yeah.
control the flex in each direction. And that was so cool when he said, this is easiest I've walked up and down inclines. And it was a $20,000 device.
20,000, this cost us less than 500. Something we got. So, but kind of going off that, like when everybody has their unique, you know, our FR for this, everybody's got their, how they're gonna do it. Just kind of bring them all together, that's another thing in itself. How do you connect the ankle to the foot, and how do you connect the foot to the toes?
Yeah.
That's like, once you think you have your FR, you're like, okay, well, we gotta make a little change, and make sure everything fits together, so. I'm sure.
Yeah, that was one thing I did go into, the physical integration. I don't know if you were here when I talked about that, but yeah, so that's what he's talking about there.
So going forward, and considering this is a very democratic process, there needs to be an FR of what all of these groups are trying to do, and then break down, you know, to sub-FRs. And so my question is, when does that happen? How does it happen? And we need to think about that relatively soon.
Yeah, we got started, I think we started Axiomatic Design, it was, I think in August, maybe. I don't think it was that early though. And
I'm
then-
not talking about teaching them Axiomatic design.
Well, I'm just.
So we're gonna do that, but how many groups are we gonna have? 6?
Well, we've got to, in the next few days, we need to sort out registration, see how many people are still serious after suffering through this meeting. Is there anybody left in the project? And then I've got to sort of assess, all right, how many do we want? I think, where's that list? Is that list around? So I can tell you where we were this morning or last night with this. So right now we've got 11 people registered to do the bamboo bike, and I'm sure there'll be a few more. Is there anybody here that wasn't registered that will?
None of the management students registered. Do we register with you?
Yeah, none of the managements have been registered.
Right, no, I'm talking about just the MEs.
Right.
So are there any changes? Were there any MEs that were registered to do the bamboo bike that want to bail after this meeting? No, okay. Are there any people that weren't? No, that's a success. Right, maybe you want to sneak out before you bail. We'll have to see what happens. And then, is there anybody that wasn't registered yet, who just emailed me and said they're interested? So are we going to pick up another one, or you out of here?
No, I'll register
Okay,
today.
all right. I figured people were busy with classes, so it'll take a little while to sort this out.
So roughly thinking, without making decisions, that's either 3 groups of 4 or 4 groups of 3.
Yeah, something like that.
Okay, and then we definitely have 2 in school
Yeah,
business.
right.
So that is a total of 6 at high end.
Yeah,
And then we need to figure out, obviously, how to do the decomp for the whole MQP.
right.
And then each group gets their own FR, then they decompose.
Right.
The FR.
That's right.
So you guys see
Yeah.
where this is going?
Question. So at the end, all 3 or 4 groups will come up with one bike, or each group are coming up?
No, we'll come up with one bike.
Okay.
And so the decomposition will be things like testing. Let's make sure it's safe. Production design. In other words, how are we want to do this in less than an hour, and so material selection, process selection, joint design. I think the gusset design looks to be a very powerful technique for, because everybody else has tried to sort of grab it as if they were welding bamboo to something, but you can't do so. If you look at the current bamboo bike things, it's like a complicated ankle taping job, and it's expensive because they're using carbon fiber, and it's messy because it's covered with epoxy, and it takes 2 days, and they get $2,000 for somebody coming in to do their own bike. So this obviously isn't the right solution. So I see this gusset design as a big advantage. By the way, for the record, this is not a public meeting. This has not been a public disclosure or any of this stuff. You still don't have IP protection. We're not going to have everybody sign non-disclosure agreements, but keep in mind that the solution that they have to the bike is not yet protected. The ankle, though, is. The ankle joint is, but he didn't see too many details in the ankle joint, so.
So they're intending to protect it.
Yes. I didn't talk about patenting and stuff, but there should be lots of opportunity on all the projects for that. It's up to you guys, and I encourage you to do it, and we'll work on it.
Anything else?
There's a fluids lab after this?
That's right, there's a fluids lab after this. So for those of you who don't know it,
Did you guys have any previous manufacturing experience?
No, not really.
So that was fun.
I was just gonna comment on that. If you plan on actually physically creating something, it's a good idea to talk to someone who works in one of the machine shops on campus or the manufacturing labs, to be like, hey, we're thinking of doing it like this, and they'll probably say, no, that's way too expensive, you can't even do that. And they'll give you a better idea. So talk to them before you finalize any ideas of actually physically integrating or purchasing materials. Like, as Jared said, don't buy a huge brick of aluminum because you can't machine it very well. So yeah, if you're
I
actually,
should have headed some of this stuff off.
so yeah, if you're gonna actually physically make something, talk to someone who works in the shops and does this all the time, and see what they have. They usually have really good employees, and they can always then be like, all right, well, we'll help you with this, and sign up for this, or it just really pays to talk to them because they know more about how things are machined and made than you do with no experience. But yeah, we had no experience, which is why our the whole prototype or the proof of concept that we made, it was out of alignment. All the welds were garbage because we didn't know how to weld. All the cuts and everything were all out of alignment. It was just, we had no experience, so it was just proof of concept to say, hey, look, we made a bike and we made it, not to prove that, hey, it's ready to be sold.
I am a resident metal fabrication expert.
Yeah, and that'll be an important part of this, and so I'm glad to have you on board. So we should discuss this over. I have maple sodas, which are very special. My friends are in the maple syrup business.
Vermont thing?
Yeah, it's a Vermont thing. So for those of you that, and those of you that don't think you like maple sodas, I have a little bit of iced tea and there's some beer, which I'm not advertising because alcohol's not a good solution, right? But in case there was somebody that wanted some, in 2 cases. And I've got some stuff to eat too. So my apartment is in the brick building in the corner of the park, in between Theta Chi and SAE. So does everybody know what that is? It's 606. Go in the front door, look for my name. I can't remember what my number is, and you punch that into the keypad. It rings my cell phone. I can buzz you in, and I'll be walking over there. People